Well, we're getting down here near the finish. In this problem here, we want to construct the graph. We actually want to draw a graph that has a domain -5 included up to 7 not included. So how about if we do this? We want this to be a function. So what we're going to do now is we're going to start someplace on the left and just go either always up or always down. Right? We're never going to turn around and come back. Just always up or always down. That will for sure get us one, but if we don't want to come back, so we could do this. Start here, up, down, up. As long as we keep going to the right, we're going to be okay. So let's start here. Now we can go anywhere here. We want -5. So where's -5? So I'm going to count here. Here's the origin. 1, 2, 3, 4, 5. Now I'm going to start anywhere here. You could, there's infinitely many of these you can start anywhere. So how about if we just started right here? Now, -5 is included, so I'll draw an actual point there. And now, as long as I do this, as long as I go always to the right, doesn't matter what kind of verticals we make, any kind of verticals, even a straight line would do it, I'm going to go to 7. Now, 7, I'll do this on the x-axis, is 1, 2, 3, 4, 5, 6, 7. So as long as we go anywhere here, we'll have a function. So let's try this. Let's graph this like this. Here's 1, but when I get to 7, I need an open circle, right? An open circle because this 7 is not included. All right, so there's one possibility. Here's another one. Could have written just like this. Here's another one. But here's one that doesn't work, right? That does not work because it comes back on itself. And on to 34, what we want to do is fill in the input column right here so that the table does not define a function. So let's just start picking some numbers here. Now, it doesn't matter which one you pick. Just start someplace. Maybe we start with a 1. So far what we have is that a 1 goes to 10. Now, we don't want it to be a function, so what if we just made 1 go to that 11? So put in another 1 here. Now 1 goes to 10 and it goes to 11. So right away it's not a function. So then we can just write 2, 3, 4. As long as we have 2 of these numbers, 2 of the same number in the input column, this is not going to be a function. Now in 35, our last problem, we did not actually do this, but what do you think f plus g is? Here's f, here's g, f plus g. So here's f, 3x plus 4, plus, and then the g is 2x plus 1. Let's add these together. 3x and 2x is a 5x. The 4 and the 1 is a 5. And then what we want to do is evaluate this at 3. So why don't you just put a 3 in there? So how about if we get 5 times 3 plus 5, 15 plus 5 is 20.